I'll start with the EH introduction. EH Technologies is a premium IT and consulting company. Over the last 10 years, we have taken over 15,000 sessions across the world for the clients like Juniper, Honeywell, Cisco, Intel, etc. As a part of B2B programs, we wanted to introduce our AI ML Bootcamp program and give you an insight to the quality. We promise you as a purely technology-driven learning partner. We hope you enjoy this program and request you to check our website at www.ehit.com to see our complete course catalog. And coming to the instructor part, Deepan Raj is the instructor for the day, and he's the young and enthusiastic trainer. He's a senior consultant at EH India Private Limited. And it's great to inform you that Deepan is a part of official India Book of Records for conducting AI to 700 plus students on a single and attempting Guinness Book of Record by this year end. Deepan, can you hear me?
Yes, Mubarak.
Okay. Guys, before Deepan start the session, I just wanted to let you know, if you have any questions, you can use the chat window and you can raise your hand. Okay, we'll be giving you time for Q&A at the end of each module. You can raise hand or you can type the question in the chat window instead of speaking directly here. You can raise hand and you can type the question in chat window. Hope I'm clear. If you're in between, if you're facing any bandwidth issue, if you're logged out, you can join in with the same link again. Okay? Guys, hope I'm clear on this part. Okay, looks good. Deepan, you can start with the session.
Yeah. Okay. Thank you, Mubarak. Thanks for the introduction. Hello, everyone. Let us start the introduction part of AI and ML because it's already been dragged for more than 25 minutes. We'll start the session right away. So I guess the PPT is well and visible, right? Yeah, I believe so. So we are, today's session, we are going to look about AI, CV, and ML. So you will get to know the terminologies, after a few slides. So we'll be looking on these three core techniques. So coming to the first slide, artificial intelligence. So artificial intelligence is like a new trend right now. So everyone, right from the startup to the biggest companies, everyone have started to use this keyword AI. Whether it is a coffee shop or it is a very big companies like Google or Amazon, everyone is like fascinated on using AI because the power which it has as a key area which can be driven the company to a different viewpoint. So that is why AI is like dominating in almost all the areas. So actually, I'm from electronics department. So you might be like believing like, electronics engineer doesn't have much knowledge and much interest in the coding areas. We will not be a very big geek. But anyways, when I started to learn this AI, I was fascinated on looking on the outputs, which really like forced me and drive me to learn a lot of things. So believe me, it is very easy. Everyone will like, little worried on, whether I should be adapted to AI, whether it is very difficult. A lot of questions will arise in your mind. But don't worry, in this session, you will get to know about what is AI. And after that, the course which we are going to join will have, pure hands-on programs and very easy tailor-made stuff. So that, you don't feel a single sweat on like doing it out. But anyways, let us go to the topic right away. So when I say AI, a lot of things comes in your mind. For me, it is the Terminator. So, it is a very good movie, a very old and good movie, and it has a lot of futuristic, ideologies and futuristic application, which was developed way before, in 1990s. So you can see this picture. The hero is like looking onto the vehicle, and he's like making an analysis whether the vehicle will matches I mean, height, I mean, whether it's height or, and its physics. So likewise, there are like a lot of futuristic applications which was developed. I mean, the concept was made, I mean, back in 1990s and back in 1970s. I mean, the theories are very old, but I mean, people will be like wondering why. I mean, why it took this much time to, I mean, for this particular technology to break up these chatters. But anyways, we'll see that later. I mean, when I say AI, a lot of things are there. So one such thing is like people believe AI will, replace human beings, replace the job opportunities. I mean, that is partly right and partly wrong. So it's up to us to catch that particular train. If you are not catching that train, we might be in a difficult situation. But anyways, few myths are there in AI which people understand in a different way. So we'll see like what are the myths of AI, and after that we'll go into the chapter, go to the session one by one. So the first mythology is like AI will solve all our problem. So no matter what, for example, if you want to go to your shop, if you want to like buy something, AI will do it. If you want to learn something, AI will learn and it will teach me. So this is how, I mean, people are thinking like AI can replace everything. AI can do everything. So I mean, that is actually because of the movies which we saw in, I mean, in the Hollywood and the other other words. I mean, the problem is we haven't reached there. It will take a lot of time to reach that spot. Even though if we reach that spot, people will not, I mean, do stupid things like we do in our movies. So the first mythology which we want to break out is like AI will not solve all the problem. So it will assist. It will help us to automate few solutions, which will be done in a regressive way, or it's a difficult way to do it out. So AI will never solve all the problem, but it will assist. So that is how AI works. So because a few of the greatest companies are like involved, like Google, Microsoft, IBM, like everyone, Amazon and stuff. I mean, they have created a lot more good technologies. I mean, Apple Siri, Microsoft's Cortana, and DeepMind, Google. Google have released a lot of applications. But anyways, even though they are tech giants, I mean, they cannot, I mean, create wonders in few years. So we should keep that in mind. The next thing is AI is like human intelligence. So if we, I mean, it is like much more similar to the first mythical point. I mean, AI is just like human being. If you train the system to, I mean, look for apples, it will just look for apples. So if you show a pineapple and I mean, make your system to see, I mean, tell me whether it is apple or pineapple, your AI system will fail because it is not yet learned about that particular features. So that is what we need to understand, because our human brain is like very superior than the technology, than the hardware, than everything which is made till now in the earth. So we cannot like compare our human intelligence with AI, because we will learn it very faster. Because I mean, there is no, I mean, we don't want to like, I mean, there is no way of coding, I mean, your brain, like, I mean, include brain.h and do something and learn this thing. We won't do that. So every learning activity will be like done automatically. For example, the baby learns to cry after its first birth. So no one taught the baby, no one programmed the baby like it should cry after the first birth. I mean, riding a bicycle, I mean, looking for the colors, I mean, identifying people. Even for an instance, I mean, if you go to a mall, if you go to a public place, you can watch all the people at an instant, and you can see like what are the brand of t-shirts or brand of shirts where they're wearing. I mean, whether they're, I mean, wear a very branded t-shirt, it's a very different fashion clothes. I mean, you can literally see all the things in an instant. It's not like an instant, less than an instant. So that much amount of processing is done in human brain, but not in AI. So all we need to do is we need to train the AI in such a way that human, I mean, day-to-day activities will be assisted. So that is the second mythology. The third thing is, I mean, this is very bad. I mean, AI learn on its own. Yeah, I mean, the current trend is like, I mean, moving towards that area, but I cannot say like, I mean, AI can able to learn on its own. So there are like few parameters, not like few, many parameters have to be taken care of, so that, I mean, I mean, successfully pass those information. For example, you will get a lot of memes like, what if like I mean, get an access to Stack Overflow or like GitHub. So I mean, it will be the end game. So that won't I mean, officially won't happen in the near future. But people are trying to create algorithms that can able to learn from its experience. So that is how it's done, but it cannot learn like human beings. So it will take time, because when it comes to AI, a lot of management, a lot of big companies, a lot of people, even us, think like if you use AI, you can solve any problem you want. So we just want to make sure that doesn't happen. So we should be like clearing our heads. So these are the three myths which has to be understood by the people who are listening to this. You need to be well versed in this part, because if someone asks you whether I can do this and do that, you should be in a position to say them you cannot do all the things. So anyways, in my standpoint, artificial intelligence is nothing but an intelligence which is given by us. So that is an artificial way. It's not a human intelligence. It is not a natural intelligence. So an intelligence which can run or execute with a minimal number of user inputs at the runtime. For example, if you create an algorithm to detect to count number of peoples, it will count the number of peoples. It won't ask you suggestions. Whether it is a kid, do I want to add this guy or something like that? They won't do that. But in this in this particular application, it will count the number of human beings, but obviously it will never count the number of vehicles, number of other animals which is crossing that area. So that's what I say. So AI is a system which can be used, which can be deployed, and it requires minimal number of user inputs. You might be like asking, okay, so only counting human beings, or doing this and doing that will be an AI. Doing some awesome things is AI. I would say that is not actually an AI. Everything which we have right now, from our TV remote, from our other remote controls and your all the application, electronic goods, embedded systems and stuff, as a part of artificially intelligent program. So if you press a button, your system, your AC might turn on. But the problem is, when you like accidentally turn off the AC and you are like standing inside, it doesn't have an intelligence where it can able to understand, okay, I should not turn off the AC. The user has made a mistake. So it is not that smart enough. So in that area, people are working and trying to increase the smartness of the particular technology which they have developed. So AI is like growing very, very fast right now. For the past 5 years, it's a very big keyword and a trending keyword in Google, key search. So this is known as AI, artificial intelligence. So in AI, we have a lot of subdivisions, like the terminology is known as machine learning, deep learning, and you might have heard about some terminologies like image processing, computer vision, sound processing, natural language processing, data science, data mining. There are a lot of terminologies which comes under the shell known as AI. But in that part, machine learning is somehow a superior part of AI. I can say it is a stronger AI because, as I said earlier, a remote controlled AC is also an AI, but we cannot like compare that particular system with, with the machine learning system, which is like created using a machine learning application. So machine learning application can be termed as a stronger AI, whereas the overall AI, lot of application which was created can be like termed as a weaker AI. So as I can say, machine learning is nothing but, it is like a system which is going to be, the user inputs before learning. Making it to learn. We'll be like giving very less of user input. For example, you don't want to, construct a lot of conditions, lot of flags, and lot of loops. It's like, you give some data set. You do some feature extraction, you do some classification. Obviously, using those images, it will try to learn what kind of objects or what kind of scenario it has to learn. So it is not like import images one by one by one. Telling that look for this portion and look for that portion. You won't like giving lot of inputs to the system to make it learn. So it is like a more of an abstract kind of a learning where you just create an architecture, an algorithm. That algorithm will be used to learn your inputs and like predict your output as well. So that is how machine learning can be termed. It is like much more similar to your AI definition. But anyways, on a technical note, I can say machine learning is nothing but improving with experience at some task. So this is very important. So if you give a task to the system, it will try to execute it. It will make some errors, obviously. So based on the error, there'll be a feedback. You can give a feedback and make it to improvise based on the rewards. I mean, it is one part of an AI. You can't say, I mean, this is the actual definition for machine learning. But to my knowledge, I mean, this suits the best. I mean, improving with experience at some task is known as machine learning. So yeah, I told about AI. I mean, what is happening right now, and few parts of machine learning. So then, what is computer vision? So whether it is a vision or it is image processing, I mean, what it might be. On a simpler note, I can say the computer vision is nothing but, I mean, we are going to give a vision to the computer. It's a very simple terminology I can say. I mean, we human beings have human eyes, which can be termed as human vision. This computer has a camera, so using that camera, you're going to take the data, you're going to pre-process, you're going to do some pre-processing, image processing and stuff, and you give those data to the machine learning model. I mean, that is how computer vision works. Because believe me, I mean, there are like lot of subfields in AI. For example, sound-based processing, I mean, data processing, NLPs, and vision-based. So in that point, I mean, vision-based processing is very difficult and it is a very challenging thing to be done right now. And a lot of attention has been like, I mean, gathered in this particular part. Because let me tell you why. You will get to understand in the later slides. But anyways, when you like try to combine this machine learning with the computer vision, I mean, it is like one of the deadliest combo you will ever achieve. I mean, you can create, I mean, easiest application. I mean, with the, I mean, what is it? I mean, when you have the power of machine learning with some image processing notations, you can create application at ease. For example, I mean, let us take a license plate detector. I mean, when imagine people are, I mean, driving their car to the malls. I mean, the security will stand there. I mean, he will, I mean, he will note down the numbers. He will give you a token. But what if it can be automated? Yes, obviously it can be automated using some image processing, using some machine learning technique. You can able to find the license plate where it is located in the car, and after that you can crop it. You can able to understand what kind of characters which is inside that license plate. So it can be automated. Likewise, there are like lot of application, and even in the, I mean, the latest consumer electronics showcase, a company like introduced, much more similar product to this Amazon Go. I guess you guys know about Amazon Go, I believe so. But I will show you that video. Anyways, I mean, they have created an application with a small camera. They can able to track the number of products which is in their shopping cart, which is in their shopping mall. So it's a very simple application which used a small camera, and using that they can able to, I mean, understand like how many products are there. So that is how this vision and machine learning are like combined. It creates a simple and a cost-effective solutions. Even companies are planning to, I mean, automate this parking lot. Parking lot is like, I mean, you want to understand like how many car spaces are available, I mean, in the parking lot without using a sensor. You can use a camera. You can fix it at the top. You can look for the free spaces and you can notify the users. So rather going for sensors for each and every parking lanes, that will cost us high. But using a simple camera, that will be like helping us, I mean, way more easily. So as I told you earlier, computer vision is one of the input for ML. I mean, there are like a lot of inputs like NLP, sound, and data. So like other forms of input. We'll see that later. So yeah, as I told you, I mean, this is the actual boundary of AI. So AI has been there for a long time. I can say this is a weaker AI. This machine learning is a stronger AI, and this deep learning is a subset of machine learning, which is even more stronger than the other part of this AI, field. So this is how the core strength is being like strengthening up as the days goes on. So we are like migrating from the weaker AI solution to the strongest AI solutions. So this is how it is like made out. So if anyone, people are quite confused, I mean, with the terminologies. I mean, whether AI is different with machine learning, or deep learning and machine learning is different from AI. So what is what? I mean, they're like confused. But it is like everything is the same. Everything, I mean, machine learning and deep learning belongs to a subset of AI. So that is how we can able to put a notation to all these terminologies. So yeah, and these are pretty famous applications which was developed using AI. So one is like Google Lens. I mean, I guess on Google I/O 2017, they have launched this, I mean, application known as Google Lens. So this Google Lens is like, I mean, one of the prettiest and one of the best application which triggered an alarm to all the other companies, because Google has entered into the AI market officially on 2017, but unofficially they were like into the market 20 to 25 years back. But anyways, I mean, these guys are like, I mean, created an application where it can able to, I mean, do some analysis using images, using real-time images. So that is one thing. And then Amazon Go, I mean, they have like made a shopping complex where you don't want to like, I mean, check out during when you take some products. And some buzz keywords like autonomous cars, I mean, humanoid robots. I mean, autonomous cars, yeah, I mean, people Waymo, Google's Waymo, and Audi, Benz, like all the companies are trying to do this autonomous cars. One day or another, you will get it soon. So let me show you a video for the ones who doesn't know, I mean, I haven't heard about this Google Lens. I will show this video. You might get some idea like what is happening inside. So
this, we are able to understand the attributes behind the picture. We realize it's your boy in a birthday party. There was cake and family involved and your boy was happy. So we can understand all that better now. And our computer vision systems now, for the task of image recognition, are even better than humans. So it's astounding progress, and we're using it across our products. So if you use the Google Pixel, it has the best-in-class camera, and we do a lot of work with computer vision. You can take a low-light picture like this, which is noisy, and we automatically make it much clearer for you. Or coming very soon, if you take a picture of your daughter at a baseball game and there is something obstructing it, we can do the hard work, remove the obstruction, and have the picture of what matters to you in front of you. We are clearly at an inflection point with vision, and so today we are announcing a new initiative called Google Lens.
So I guess the audio is not that clear, but anyways, I mean, this is, you can Google about, I mean, Google I/O 2017 keynote speak. I mean, where you can able to, I mean, find this video. I mean, you can see this Amazon Go's, I mean, great video.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. You pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it just walk out technology.
So I mean, this is another video where you can see, I mean, people take products and they just walk out. I mean, automatically your I mean, wallet will be charged. So that is how they have developed. I mean, believe me, I mean, this particular technology, I mean, the product which Amazon created is a very great, I mean, initiative, but it has a lot more, I mean, disadvantages things as well. For example, if you like swap the products, I mean, obviously, I mean, there'll be like no one to swap the products. If you swap the product from $100 product to a $1, and you take from there, I mean, you'll be charged just $1. So there are like a lot of glitches which is happening now. I mean, they are like seriously like working in that, I mean, area to like neglect it out. But anyways, we are at the starting of the new era known as AI. So people have started to create products. I mean, back in 1970s, I mean, people have started to do some research papers, I mean, on AI. Till now, people are doing research papers. I guess, I mean, people are well known about Andrew Ng. I mean, it's one of the grandmaster of AI. He just gave a public speech where he told, like, stop creating papers and try to make a product that actually be helpful for the people. So that's what the statement they have given. So because we are in that stage right now, because we have the perfect processing speed and we have the data as well. So we are in a stage where we can able to create the actual product which was theoretically proven. So we are in that stage, and it is a very good time to jump into this field. So anyways, people, maybe 5 years back, when I started to learn this AI, no one knows about it. So when I say I'm learning about machine learning, people say like, what is machine learning, man? So I just, try to give some free, lectures to the students, to my friends and colleagues, to the staffs and everyone. No one, show up on that time because they seem like machine learning is not, not yet there. They believe like, but as soon as, some giants like Google and Nvidia, entered into this market. The demand for this AI is like grown. I can say, it is also because of the digital data which we have right now. Because all the people around the world, or most of the people, are using Facebook. We use WhatsApp. We use a video chat. Even this is a webinar. So all the things, which we use, it is like mostly like digitally oriented. You can get a lot of data. You can get a lot of images. So for the machine learning system to learn, it should have a lot of data. And since we have a lot of data, it is the best time to create some good application. That is one part. And I can say another area where is also an important thing. It is like the computational part. Our human brain has the capacity of more than 10 million teraflops. Whereas to the state-of-the-art model, state-of-the-art hardware which we have, will have some teraflops of like maybe thousands or 2,000 teraflops. That's the maximum flops which we have right now. So anyways, Nvidia is the key contributor for this AI revolution. Because back in 15 years, Google have used a big server, big stack of computers which is connected together, where they use that much amount of big server to create their AI application. Because obviously the processing speed should be like very high for a very big data. Imagine if you have 1 million data and you want to process it. Obviously it will take a lot of time to process, so they created a very big processing unit. But now the Caltech University just now adapted their AI lab, where they have a small setup of Nvidia GPUs. So Nvidia has cracked the market, guys. Because of them, the revolution has started way before. They use this. They somehow cracked a logic where we can able to use the GPUs to train the data. So since the GPUs are like mostly used for the display part, to render the graphics, they have found a way to utilize that particular parallel CUDA cores to be utilized for the training of the machine learning systems. So that is where this data, increasing the data size and increasing the computational power, serve to be the perfect time, and people have started to use it now. So that is how I can say about why AI now. What is machine learning? Maybe computer vision. But now, actually, let us go to the topic right away. Let me ask you a question. When I say the word Apple, a lot of things comes in our mind. People will say Apple is a fruit. I can say Apple is a company, iPhone and stuff. Some people will say Newton. Apple is a great discovery by Newton, something like that. So, when I say Apple, lot of things and lot of images and scenarios and situations, where you would have encountered the name Apple. So I can say, let me take 3 objects. For example, a red apple, a green apple, and an Apple logo. So as soon as I shown this image, I guess pretty much all the participants can able to differentiate between red apple and a green apple and the Apple logo, right? Yes. Yeah, obviously. So have you ever, wondered how you arrive to a point you can able to differentiate these 3 objects? So obviously you will have some ideologies. Obviously, yeah. These 3 objects are different in shape. I can say red and green apple are somehow same and similar in shape, and the Apple logo is different. So I can differentiate there. And also because of the color, I can say this is red and this is green and this is somehow ashish blue. So likewise, you are able to differentiate these objects based on their attributes. Even when you enter into your office or a college, you can able to, categorize your friends. You can able to identify each and every face is different to each other. So you are using some attributes to differentiate the different type of objects and classes. So I can say we mostly use these three attributes. One is color, shape, and the texture. So the first thing is color. Yes, it is obvious. Red, green, and ash. All the three objects are different in color. You can differentiate with the color, and also the shape is somehow different to each other. And there comes the texture. So texture is nothing but a pattern. So everything has a texture. For example, two similar guys are wearing a blue T-shirt or blue shirt. Both might be blue, but the pattern, but the texture which is inside that shirt will be different. So we can use the pattern, we can use the texture for an object to differentiate between other objects. Because if I show you an artificially made apple, we will be in a position to differentiate between the original apple and the artificial apple. So I'm not going to tell you guys to taste the apple, because we are in the standpoint where we just want to use this vision part. So using the vision, you can able to understand, some naturality will be there, some tiny pigments, some tiny dots will be like more perfect in the natural apple than the artificial apple. So that is how we differentiate products. So this is how our human brain is also doing it out. So it automatically like find the data which is unique to each and every object. So based on that, it differentiates. So let us see. As I told you, our human brain is like much more superior. It like easily classified by the time I showed you. But let me try to like use our computer to read these images. So what will happen? So when I try to read these two images, I get chunks and chunks of numbers that really doesn't make sense. Is that right? Yeah, obviously. You can see numbers. You cannot say, this particular part, this particular area of numbers represent the color of the apple, and this part of the numbers represent the the shape of the apple. You cannot say like that, right? So we cannot able to understand the numbers which is actually like featuring this particular objects. So that is known as the semantic gap between human being and the computer, because human being can able to directly utilize your numbers and read those in a very easiest way, but the system cannot able to understand. So we need to teach the system in some way where it can able to identify key numbers that actually defines this objects. So we can say it as feature extraction. So feature extraction is the terminology which we can use where we are going to give some meaning to the numbers. For example, as I told you, we have three attributes: color, texture, and shape. So let me take a color image descriptor algorithm. So if I use this algorithm, I'll be getting the mean and standard deviation of red, green, and blue, RGB. So using this RGB colors, I can say which has a maximum number. For example, for this number, obviously your blue and green will be like somehow higher. If for a red apple, this will be like very higher. The red part will be like higher. So using that, you can able to understand, okay, this is a composition of the dominant color is red. So using algorithm like this, there are like a lot of algorithms for feature extraction, but using this algorithm, you can able to pinpoint the numbers. For example, if I use a color image descriptor and find the mean and standard deviation using these numbers, I'll be arriving with some 6 numbers, right? So using that 6 numbers, you are actually you have given the meaning to all this very big chunk of numbers have been like changed right now. So we are going to make the number more meaningful so that our artificial intelligence, our machine learning model doesn't confuse, because it's all about normalization. So people believe that, I just copied a code from GitHub, for example. I created a machine learning algorithm. Someone has created an object detector. They downloaded it from GitHub, and they use their own custom-made data set, and they like pushed it to their put to that application. So what will happen there is, they don't understand the machine cannot learn everything, right? So the number should be like much more unique to different objects. For example, for red apple, for green apple, and for apple logo, if I get number 100 for all the 3 feature extractor, obviously the machine learning will not learn, because I say if I get an 100, I can say this is red apple. If I get another 100, I should say this is green apple. So the system will be in a dilemma. Okay, which 100 is for which? mean, which object do I want to go? So there will be a very big problem. So we need to make an algorithm in such a way that the data which is like taken from that image should be like much more unique to that particular class. So this is the core ideology which we need to understand. So feature extraction is nothing but we are going to quantize the data to a meaningful way, where each and every class data are much more unique to each other, so that the algorithm which we are going to create can able to learn very easily. Because back in LKG or in a primary schools, if I show you A and I teach it as A, you will learn it as A. But if I teach it differently, obviously you will learn it differently. So we need to make sure things are pretty clear in terms of feature extraction. If the feature extraction is very good, your machine learning model will succeed. If it is bad, if the feature extraction is very bad and the data is much more similar to each other, you cannot expect a good accuracy. You cannot deploy this product. So because there's a huge gap for the people who like started to use this AI application. People like, are not well versed in this particular area, so that they think like, even the algorithm which was created by Google is not up to the mark. So it's not about the algorithm, it's about normalizing the data. So whether you can take an image or a sound or an NLP, so whatever input data you want to go, you just want to make a way to quantize these numbers. So that's the standpoint which I'm saying right now. So feature extraction is nothing but we are going to quantize the data in a meaningful way, so that it is unique to all the other classes. So it is pretty clear, right? So do we want any, is everyone clear in this part? So I just want a quick feedback, because this is important. Feature extraction is a very important topic in machine learning. Without this, you cannot able to, cope up with the later slides. So yeah, I take it as an S, guys. Yeah. So yeah, I take it as an S. Okay, let us go to this topic. Yeah. So
if you have any questions, you can speak up. No problem.
Okay. So we'll go for the next topic. So feature extraction is pretty clear for us right now. So a small ideology where we can able to differentiate, take the numbers which is actually meaningful. Okay, great. So these are some of the standard algorithms, which is being used for the feature extraction. Because as I told you, there are like just three kind of features. One is shape, texture, and color. So most of the dominant features, most of the dominant areas will be in these three areas. So there are like a lot of different algorithms where taking of data, taking of numbers will be like very different. So we'll see this algorithms later. We'll go for the next slide. So as I said you, feature extraction is a very important task. Yeah, that is right. But how you do it out? So how you create, how you make sure, your feature extraction is perfect. Let us take some challenges faced. For example, you can see, the two images. One is a sheep with a green background, a grassy background. Another one is a dog, even that as a grassy background. So when let me like try to, extract the shape feature for this particular image. So when I try to take a shape kind of a feature, I can somehow able to get the data for the sheep and dog. But the problem is mostly the background, as the largest area than the foreground. The foreground area is less, but the background area is very high. Even in this case, the background area is very high and the foreground area is very less. So when it comes to pixels, for example, this is a 1000 cross 1000 image. So I have 10,000 pixels that represent the foreground, and the rest of the pixel 90,000 pixels that represent the background. So the dominant pixels are from the background, the non-dominant pixels are from the foreground. So our aim is to identify the sheep, whether the given image is sheep or dog. So on that time, this grass will play a crucial role, obviously. So when I try to extract some features, obviously it will extract the shape feature for this grass also, right? So obviously your system will fail, because you never know. If you like collect images and you try it with the machine learning model, you will never know. Why you are getting a very bad result? Why am I getting very bad result? The data set is very normalized. The image clarity is very good. There is no, watermarks and there is nothing. But why do I get a very less accuracy? That is because of this background. So if you are going to create an algorithm, an application that involves background, we just have to try for a way to eliminate the background to the minimal amount, because I cannot use a magic wand of Photoshop's tool to crop all the images one by one. Imagine I'm having a 10 lakh images. I cannot crop one by one. So we need to make sure somehow the background is eliminated. So in this case, if it is a greeny background, you can able to apply some filters where you can able to eliminate the green portions alone. So this is one of the important challenge which we need to understand, because people can get lot of codes in GitHub. People can get lot of codes from Stack Overflow or others websites, but we have to understand whether this code, whether this application and the algorithm will actually work or not. So that is the beauty, and that is the thing which we are going to emphasize more on our course. So coming to the point, background is a very important challenge which we need to mitigate when we create an application. So coming to the next challenge, viewpoints. Yeah, that is obvious. For example, these 5 images represent the same chat, right? So when I try to extract some shape kind of a feature for this chats, obviously 5 chats will give me 5 different features, 5 different shapes, because even though it is showing me the same chat, my data will be very different. So we need to make sure if you're going to create an application that has a different viewpoint, we need to make sure we have enough number of data set. Data set is nothing but enough number of images. So for example, if you want to identify chats, you take images images of the chat and all the viewpoints, isotropic view, whatever view you can take it from there. Because also you can also use a single viewpoint where you can able to train a machine learning model. You will get a good accuracy, but when you deploy the model in real time, you will face a lot of problem, because your particular application can able to recognize the chair only in one viewpoint. So if the chair is somehow tilted or to a different viewpoint, your application will fail dramatically. Because implementing AI is very different than learning or doing some pet projects. So we need to make sure there is a huge difference between these two things. So in that point, viewpoint is a very important task, very important property which we need to mitigate. And the third thing is scale variation. This is also a little bit important topic, because take an example of an autonomous car. Imagine the core functionality of autonomous car is to not hit the human being. So that is an important functional safety application which people will do. So for example, I'm going to detect human detection algorithm and I'm going to put it in the car. So in this autonomous car. So accidentally what I did is I take the images of the actual size of human beings. For example, the human being size may be vary from 4 feet to 6 to 7 feet. So I take images in that size, maybe a 300 cross 300. I just give to my system and my system has learned. So what if, imagine a real-time scenario where you are driving a car at 80 to 100 km per hour. So, you can see objects for far more than 500 meters. If it is a straight road, you can able to see the objects 500 meters way before. So on that 500 meters, your image of humans, which is crossing the road, will be very, very small, right? So if it is very, very small, your system is trained for only for one size. So you cannot expect the system to understand, detect the human beings, which they are very far. So you cannot say, it is easily achievable. So we need to make sure we mitigate this problem. So in order to mitigate this problem, it is very easy. We can just resize the image one by one. So using the resize operation, you can able to do it all. It's not we need to create a data set with different sizes. It will be taken care in the application deployment point of view. But anyways, we need to make sure our application has the mitigation effect for the scale variation as well. Great. The next thing is occlusion. This is a very challenge right now. Till now, there is no good solution for occlusion. You can say both images represent a dog, but the right image shows you only few portion of the dog. So there will be a dilemma whether it is a dog or a cat or even a human being. Maybe, yeah. You cannot pretty sure whether this image belongs to an animal category. So what if I eliminate this image? The left image, if I didn't show you at all, this left image, people will be in a dilemma whether this the right image is actually dog. maybe a classic example, I mean, where we created a product for a company where we need to, give an automatic attendance system based on the face. So whenever employees walks into their company, automatically the system has to understand the face and should mark and pass to the employee. So we have designed that algorithm, we deployed it correctly, but they came back to us and they like told like we have a lot of problems. It's not working at all. You know the drill, right? The client say, they're not technically strong. They just tell the word it's not working. So we went there and we noticed that the application is working fine, and we came to know that is because of occlusion. For example, for ladies, they usually cover the face, only the eye part will be like visible. For gents, they like used to wear a hat or a coolers. So that occlusion actually destroyed our application. So this occlusion is a very important. Yeah, someone opened their mic. I'm getting a feedback. Can you go to the mute? No, it's not been mute. Okay. So occlusion is a very important challenge which has to be taken care. Either you can try to mitigate this problem, or you can give a perfect precondition. So occlusions cannot be handled. So you can give some preconditions so that your application doesn't face this part. And the next challenge is the elimination. So elimination can also be a challenge, obviously, because now we have this good cameras at a very cheaper rate. Night vision cameras, thermal cameras and stuff. This will not be a big problem, but for the academicians, we are not in liberty to buy a very costly camera. So we'll be using a normal camera, normal USB camera. So in that time, we need to make sure the color variations and things are pretty much similar to each other. So we need to find a way to mitigate this elimination as well. So the final challenge which will be faced is like the intra-class. For example, all the 6 objects which is shown belongs to the category chair, but all the shape, all the color, all the attributes are different to all the 6 classes. So our machine learning model will miserably fail if we create our application just for one chair. So if your application involves different intra classes, you need to make sure we have all the images, all the data with respect to that particular class. So these are some of the challenges which are being faced by a lot of people, or a lot of beginners. Because people, even myself, I created a lot of application. Waiting for more than 1 or 2 weeks to understand what is actually happening. Because it's a fancy word we can say. If you create a neural network, you never know what kind of data which is being transferred to those back propagation and stuff. So you will never know what kind of processing is being done. But in machine learning, somehow you can able to steer it out. But anyways, you cannot understand actually the learning rate is good or bad. So it's up to us to understand, to give a mental image whether this image will definitely work for my for my machine learning or not. So imagine you can keep it like this. For example, a newborn baby, maybe a 3-year-old baby, the baby is very new. So if you show an image to a baby, you can able to understand. For example, if I show the first image of the chair and I say this is chair, when I say a different image to when I show a different image to the baby will be in a dilemma, whether it is a chair or some different object. So that is how machine learning will behave. So we need to understand, if you have the challenges which I told you, the background, the elimination, the scales, the occlusion, the intra-classes, the viewpoints, if your application deployment has these challenges, make sure you mitigate it, or else you will be in a position where you cannot able to understand what went wrong, whether the feature extraction is wrong, whether the machine learning algorithm is wrong, whether the very image which you are given is wrong. So make sure we mitigate this problem when you create an application. So it is pretty clear for everyone. So shall we, do we have any doubts, any questions, anything which I missed out? Shall we go for the next topic?
Guys, do you have any question? Yeah, you can ask the question. You can unmute and you can ask the question, Malti, if you have any question.
Okay. I guess that S belongs to the S for the previous question, maybe. Yeah, okay. Some misunderstanding. Yeah, great. So coming to the point, I mean, till now we have seen what is a feature extraction. So during feature extraction, what kind of problems we will face. So okay, that is great. Now we have found a way to extract the data, take some meaningful data for all the images. Now that we have data, we need to find a way to make the system learn. So that is also equally important as your data normalization. So your data normalization plays around 60% of your part. Next 40% that belongs to your machine learning models. So we'll go to the topics right away. I mean, we can like categorize this machine learning into four types: supervised learning, unsupervised, semi-supervised, and reinforcement learning. So I mean, we'll go to the topics one by one. So let us go for this supervised learning. So it is pretty clear supervised learning is nothing but, I mean, a classic example, teacher teaching the students. So if the teacher teaches the student will learn. That's obvious. That's the actual criteria. So what if I show a red apple to the students and I say this is red apple? So students will understand, okay, this is red apple. Okay, so I get this kind of data. I need to label it as red apple. And I show a different data and I give a label known as green apple. So the system will understand, okay, I mean, I'm getting these data. So how do I name it? So, okay, I can name it as a green apple. Likewise, we'll be giving labels to all the data for all the images so that the system will understand, okay, I get this data and this data belongs to this red apple. And I get this data belongs to an Apple logo. So once you give enough labels to your images, labels to your data, obviously your system will understand, if I get numbers like this, I should say this is red apple. If I get numbers like this, I should say this is green apple. So as I say, I mean, let us take a small example. I mean, this is the feature extraction just made for 6 images that belong to a category known as cat and dog. So I extract, I mean, mean and standard deviation for all the 6 images. I know that, color channel statistics, I mean, will never work for this classification of cat and dog. But to an understanding, it is given the label known as cat and dog. I mean, to an understanding. So this is not the real case. So anyways, you can see, I mean, the mean and the standard deviation for cat, the mean and standard deviation for the dog. So now I can say when I get the number 57 or above 120 or 124, I can say that particular image belongs to the category known as cat. So when I get an image which is above 140 and also close to 100, I can say this image might belong to a dog. So you can see there is a dilemma. I mean, as I said about this normalization, so this data is 57 and this is 120 and 124, but this dog data is coming as 100. So there will be a dilemma whether this 100 has to be taken care of as a cat or actually it has to be taken care of a dog. So here the normalization is not that good. Your learning will be little less. But anyways, to an understanding of supervised learning, we don't want to sidetrack. So if you get data like this, I will point the label as cat. If you get data like this, I will point the label as dog. So we have a different, I mean, lot of varieties of, feature extractors and lot of, I mean, great supervised learning algorithms also. So each and every algorithms will learn differently. Like our human beings. I learn in a different way. Mubarak will learn in a different way. So that's obvious. So maybe when I was studying my engineering, so I used to use some cinematic songs to understand the expressions. So E is equal to MC square. So likewise, I mean, just an analogy. So my learning is different, but Mubarak may be like some more intelligent than me. So he will be like learning very easy. So it is up to us to decide which kind of learning will work for which kind of numbers. So we'll see that part later. But anyways, coming to the supervised learning, if we have data and if we have labels, the system will learn very easily because it is like pointing one to each other. So this is how it goes. So let us go for an example so that you can able to understand this much more clearly. So let us go for a email spam filter. So I guess we have we have this mail IDs, right? So in that mail ID we have this folder known as spams. In Gmail or whatever vendor you use, you definitely will have this spam emails. So we need to make sure I mean, the companies like Google, Intel, and stuff, I mean, they will make sure, I mean, important mail doesn't go to the spam folder. So in order to do that, we need to understand whether the particular message has some spammy words like free, I mean, $100, I mean, exclusively free for you, give your credit card details, something like that. These data, these, I mean, information will say us, okay, definitely this is a spam email. Because when you receive an email, you will be in a standpoint where you can able to understand whether it is actually spam or not spam, right? So we need to make sure that particular system works better. Because, for example, each and every one has a Google account, right? Obviously, not just one account. We'll be having 5 to 6 accounts. Yeah, even I have 4 to 5 accounts. So imagine if Google hires people to watch out your emails. For each and every email, an employee has to like read your emails. Obviously, Google need employ more than the population of world. That is obvious. So we need to make sure, we need to create an algorithm. That algorithm has to identify whether the given the mail came to use spam or not spam. So let us see like how it can be mitigated. For example, I'm going to extract the data. So feature extraction is pretty clear. So in this upcoming slides, we'll be like seeing about only the machine learning. So how you are going to classify your classes. Okay. So now that I use some image, some feature extraction for data, and I somehow plotted the data like this. For example, this red data represent the spam and the blue data represent the non-spam. So based on the email length and based on the new recipients. For example, because you will get a lot of spam from the new email recipients. If you get an old recipient, obviously it will not be a spam, right? So based on the email length and the new recipient, I'm plotting the data, and I can able to say red data belong to the spam and blue data belongs to the non-spam. So how can you classify it? A simple idea. Using a linear classifier, just drawing a straight line that can able to divide these two data to spam and not spam, it gives us a pretty decent ideology. If I get a data above the line, I can say that is non-spam. If I get a data which is below this line, I can say that is spam. So this is how you classify. This is one kind of a learning algorithm. We call it as linear classifiers. Some algorithm which was developed is known as support vector machine. We'll see that later. But anyways, using this linear classifier, you can able to classify the data. Into a simpler notation. It's like much more lightweight architecture. It's very simple, but it cannot be like used for all the applications. But it is somehow simple. But anyways, coming to this area, you can say, can I able to draw this line alone? Do I want to? Can I draw different lines also? Yeah. Obviously, you can draw this many amount of combinations, not this many. There are like infinite number of combinations where you can draw lines. So drawing lines, obviously all the lines are like splitting your data clearly. But we need to make sure which line is the best. So how you can make sure is like drawing a margin, the maximum margin for the line. For example, this line has the biggest margin for two classes. Margin in the sense the data which is very close to this line and the other class of data which is very close to this line. So this line has the biggest margin than the other lines. So this is how you finalize the actual line to classify your data. So as you can see, this is known as support vector machine, or you can say linear support vector machine as well. So using this ideology, you can able to classify the data. Great. Now, a very tricky guy. He's very tricky. He has a good vocabulary, and he tried. He like made a perfect email which actually went to this category, right? So obviously this is a spam, and you can see a very bad vocabulary man. I've made an email that went to the spam folder. So obviously his valuable mail is missed out right now. So now we have a problem where this line cannot like classify this data. This particular data here cannot be classified at all. Yeah, obvious. You cannot draw, many number of lines to classify this out. So now we have a problem. So we have data which is way more inside the non-spam area. So how we can mitigate it? So yeah, we can use some other ideologies. Why can't we draw a line like this, a crazy line like this? Yeah, obvious, we can do that. We can use, a crazy line which has no, restriction at all. It goes to all the areas and somehow make a boundary for all your data, and somehow making sure the data is classified perfectly. So we call it as non-linear classifiers. So non-linear classifiers, the name implies, it doesn't have a linear property. So you can bend on your own will. So based on the data population, whether it is spam or non-spam, I mean, your line bends out in such a way that it classifies the data very perfectly. So I mean, a classic example for non-linear classifier may be Kalman filter or extended Kalman filter. So Kalman filter is one of the best non-linear classifier. I mean, not like a best, it's the base platform for most of the non-linear classifiers. But anyways, you can use a non-linear classifier also to predict the actual classes. But believe me, you are given a choice where you can use any any two algorithms, for example your linear classifier or your non-linear classifier. So and they say, I mean, you have to make a decision. The first model is very easy and very easy to implement. It will just take 1 or 2 days to make this algorithm work, and you will get a minimal amount of errors. For example, you will get an accuracy of 90%. You won't get 100%, that is obvious, but you will get 90% in just 2 days. And they are giving you another option, I mean, that is non-linear classifier, where you can able to, I mean, actually eliminate all the errors, but it will take a month to create. So which area you will go? So we'll be in a dilemma whether to use the, I mean, okay, two errors are okay. I will stick with the simpler one, or no, I just want to make it sure it is like much more perfect. I'll go for a non-linear one. So it's up to us to decide which kind of classifier, which kind of supervised classifier have to be utilized. So I mean, people will say, okay, it's better to go to this area because I cannot like create a crazy line like this. I mean, in my development, I mean, a developer guy given to this area, I will be like choosing this part. Okay, 2 hours is tolerable, can go with this. But you know what? We have different ideologies, different techniques that actually, I mean, eliminates, I mean, the need of non-linear classifier. So I literally call it as a lazy learner scheme. So it's one of the engineers' way. I mean, we engineers find a smart way to, I mean, create classifiers. That's obvious. So as I said, you a lazy learning scheme. So we use a thumb rule to classify your data. So not just a line or not just a non-linear line that can able to classify data. So I'm going to use a thumb rule. Using that thumb rule, I can able to understand, I mean, which data belongs to which class. Okay, great then. So you can see this, K nearest neighbor. This is one of the classifier. I mean, I don't know the creator of this, I mean, algorithm. I mean, it's a very simple algorithm which can able to classify data very easily, a very lightweight also. For example, I mean, I get this data. This big data is here, right? So this data, I mean, I'll be looking for the nearest neighbors. So I'm going to look for 3 neighbors, and all the 3 neighbors belong to the non-spam. So I'll be like terming that data as non-spam. For example, take this data. Only, I mean, 2 neighbors belong to spam and 1 neighbor belong to non-spam. So obviously you will know that this particular data belongs to a spam category. So using this ideology, you can able to classify data without using a linear classifier or without using a non-linear classifier. Using a small thumb rule, you can easily derive to a conclusion. I mean, you can use it all, but I cannot say, I mean, this will work for all the categories because this is a 2-class classifier. Only we have 2 classes. What else? For example, I want to classify 10 objects, as I showed in the previous slide: red apple, green apple, Apple logo, Apple iPhone, Newton, and stuff. So there are 10 objects. I cannot use this, I mean, K nearest neighbor for classifying 10 objects. That will be like very difficult. You will be in a very big dilemma. So it will be used in some use cases where linear classifier actually fails. So, I mean, let me tell you this decision trees later. I mean, let me show you, a small demo, I mean, where, we try to classify some data, classify some images using the supervised learning. For example, I mean, I just used a small algorithm where I can able to identify the coins, the Indian coins, based on the shape and texture and the value content which is inside. So I decided to create an algorithm where I can able to understand, I mean, what are the coins which are present in that particular image. So let me go there. So don't worry. I mean, we'll be like sharing all the codes. I mean, once you join the course, I mean, this is just a sample code which I'm going to show you. We have a lot of good codes and good, algorithms, which is like somehow tailor-made by us. You can use it easily. When you like enter the course. So let us try to run this application. Okay. So when I run this, you can see it here, right? So I didn't give this image directly to my machine learning model. So because this image has 3 objects, right? So I just want to make sure I just crop this, coins individually and pass this, images one by one, so that my model can able to understand what kind of coin is this. Because that is how your image processing will be helpful. Because as I told you, image processing is a very important category which you want to master. For example, I used a simple technique to segment the circular objects and found the coins, found out the portions. Now I'm going to crop one by one. First I will crop the 2 rupee coin, second I will crop the 5 rupee, and third I will crop the 10 rupee coin, and pass this coin one by one, so that my algorithm can able to classify what kind of coin is that. So in that note, you can say, and just wait. So there is one 2 rupee, there is one 5 rupee, and there is one 10 rupee. So the total value is 17. So it is one of the simpler application which actually has your image processing at the core and to the machine learning. So you have used a simple image processing to categorize your data, to normalize. Once it is normalized, you just give the data to your machine learning model. So I used a data set. Collected a data set. Where I used lot of 2 rupee coins and a lot of 5 rupee coins and a lot of 10 rupee and 1 rupee as well. So using that coins, I can able to teach my system that if this kind of circular object with a shape attribute like this, I should say this is 2. Something like this, I should say this is 5, and this something like this, I should say this is 10. Also there are a lot of dilemmas for 5 rupees. And 2 rupees. So I used a different kind of feature extraction here. So I added, a color-based feature extraction, and also a shape and a texture-based feature extraction. So I used 2 things. Texture-based feature extraction and color-based feature extraction. So color-based feature extraction will help me to classify these 3 objects, that's obvious. And also shape features will also will be helpful for us, because sometimes the coin will be like flipped to the other direction. So you will get only this. This head as an emblem. So you will be in a dilemma whether the given image is actually 5 rupee or 10 rupee. So I use different technique. So the prime ideology is like, I crop the image. I use an image processing technique. I pre-processed it. I know the challenges. So I cropped it somehow, and I gave the cropped image to the model one by one, and my model can able to understand what kind of coins is this. So this is one of the simple example which you can see. Also we have a lot more good example which I will be showing you in the later slides. So coming to the point, I've used lazy learner scheme. We have a lot of algorithms like k-nearest neighbors, decision trees, and stuff. For example, to a simpler note for decision trees, let us take today's scenario. Our meeting is supposed to be started by 11 o'clock, right? So you wake up in the morning. It is 9 o'clock. You take decision there. Okay, I can sleep for another 15 minutes. Okay, I still have time. I have 1.5 hour time, so I can eat. I can come by 11. And you wake up at 9:30. Come on, yeah. I have 1.5 hour more left. Yeah, I can sleep another half an hour. So if the climate is too cool, okay, there is no need of taking bath. So I'm going to do an online session. I'm not going anywhere. So I don't want to take a bath. So likewise, you take decision at every point. Likewise, we are going to make some decision to understand the data. For example, you can see if the x value is less than 2, I should go to this direction. If it is greater than 2, I should go to this direction. Likewise, I'll be going, taking condition by condition, and can able to understand, the final output will be arriving to the actual class. So this is the type of algorithm which is known as decision trees. there are n number of algorithms which I'll be like telling you later. But anyways, for now you can see k-nearest table is one of the simplest algorithm. Support vector machine, so it's also a cleaner algorithm, but that cannot be used for all the application. Non-linear classifiers, and then there comes decision trees. So this is what supervised learning does. So you have data and you have labels. So you're going to give a data and you're going to give a label. Obviously, it is going to learn. So on a simpler standpoint, this is us when we listen to the actual lecture of our staffs. So the staff takes, we'll be like learning and we'll be noting the things. So next, let us go for unsupervised learning. So imagine I don't have labels to the images and I just have the feature extractor, but I don't know the actual name of that particular image. So my data will look like this. So 57, 120, 124, 100, 177, 149. So what I can do is I can say 120, 124 and 100 belongs to a class, because these three data are somehow similar to each other. I can say these three can be clustered to a single class, and this two can be clustered to a single class, and this can be clustered to a different class. So I will be getting three different clusters, because since I don't know the meaning of the numbers, meaning of the label of the particular image, I can cluster those images. So imagine a scenario. You go to a different country, a different nation which has a different language. Or a Spanish, or go to southern part of India, will have different languages. You might not be understanding the actual characters, but you will be in a position to understand, okay, this character is different from the next character, right? Maybe on a different note, you go to a mall or you go to somewhere, you will be seeing lot of faces. Lot of faces will be there. You might not knowing the actual name of that particular person, but you know that this person face is different from the next person face. You'll be keeping your own name, maybe a specs guy, a fat guy, a lean guy, a beardo, something like that. You will be like giving your own labels. You'll be clustering those faces to different classes, because you know the data are very different. So this is how unsupervised learning works. Unsupervised learning are like pretty much being used in the bioinformatics system. Where we will get unpresented data. That has to be somehow clustered. Even for space technologies, they are like trying to utilize this unsupervised learning, getting some anomalies, getting some data which is very different, clustering those data to a different class. So where you can use this unsupervised learning. So I can say this is us when we try to prepare for the examination, a day before the examination, right? So obviously, we might be like not listening to all the lectures, so we start to create our own theories based on the derivation and stuff. So this is us before the examination. So next, let me go for the semi-supervised learning. So as the name implies, it is very straightforward. Semi-supervised learning is a combination of supervised and unsupervised. So I can say, I have three images which has a label, and I have three images which doesn't have a label. So now I can say, the dog label which has 100 and another dog label which is having 150. So I can say this particular 177 definitely will belong to a dog category. Maybe this 120 and 124 might also belong to a dog category, because I have a 100 number and I also have a 149. So maybe I will also wrongly say it as these two data might belong to a dog category. So because as I told you earlier, the data is not normalized. It is not unique to each other. So obviously we'll get a wrong. It goes to a wrong path. So that is why I say normalization is very, very important. If we fail in normalization, even though if you use a state-of-the-art machine learning model, you will be in a big trouble. So in coming to the point, semi-supervised learning is a very simple node. We are going to combine the supervised and unsupervised learning to the maximum extent. So this is us when we write our examination. So we used to combine. We will become the author of that particular exam. So right, yeah. So we study. If you know one line, we will make it as a very big article. So just for a funny standpoint. But anyways, this is known as semi-supervised learning. So let me summarize once more. Supervised learning, we'll be having data. We'll be having data and the label. When it comes to unsupervised learning, we'll be having only the data. When it comes to semi-supervised, we'll have data and labels. So this is how three categories we have saw. So let us go for the final category, and believe me, this is the active area which people are working right now. This is the area you have to focus. Reinforcement learning is a very, very trendy topic right now. I mean, a lot of people, a lot of companies have started to, create products using reinforcement learning. So let me tell you like what actually happens in reinforcement learning. So for example, I have an actor. So I have an actor. So my actor is actually going to do some actions, do some action that is going to be affected to my environment. Yeah, obviously. So I'm going to give an action. My environment is changed. So based on the environment change, I'm going to give an assessment, the star rating to the particular, the star rating to the particular action. So I just get a 3 star. So I know this is not a very perfect action. This is an average action. So I'll be getting a feedback of the assessment and the actual change in the environment. So using the state and the assessment, my actor can able to understand, okay, I need to tune this data to a way where I can able to get the 5-star rating to the maximum. Imagine, you drive, you go on a long drive where you want to overtake a truck. So if you are a rookie driver, obviously you will stay behind the truck forever, right? Because you don't know the right time to overtake, because you don't have the skill, you don't have the experience. But imagine if there's a professional driver, he will be like overtaking the truck in a minute, in few seconds, because you know when to accelerate, when to decelerate, and when to make a perfect turn. So it's because you know all the actions, you know each and every action's assessment ratings. So based on the ratings, our system can able to understand, okay, if I use this kind of inputs, I'm getting the system actually working in the right direction. If I use this kind of inputs, obviously my assessment is very low, so I should not use this inputs. So this is how reinforcement learning works. You know what, Google have launched a platform where you can also train your reinforcement learning algorithm in their platform. I just forgot the name. I will try to give the information post the session. So there are a lot of platforms which was created by big companies. One such is Google's platform, where you can able to create your reinforcement learning algorithm and you can simulate it actually. So it's like simulations in the sense, giving some action, based on action you will get an assessment. So likewise, the simulation will be like happening for more than million times, so that right actions and right assessment will be taken care of. So these are the broad categories of machine learning. So supervised learning, unsupervised, semi-supervised, and reinforcement learning. So in our course, we'll be like primarily focusing on the supervised and unsupervised learning. So the semi-supervised and reinforcement learning will not be in our scope. Obviously, there is no perfect trademarks and perfect standard have been created for this reinforcement learning. So we'll try to give you some insights maybe in the course. So I guess the machine learning models are somewhat clear for us right now. But anyways, let me show you a workflow how to use this supervised learning. For example, you have an input data. You're going to extract the data. You're going to extract the features. So we can term it as feature vectors. So I can say this extracted features is known as feature vectors. So I'm going to use this feature vector and the label. Using this label and feature vector, I can able to give to my machine learning algorithm. So this machine learning algorithm will obviously go to the classifier model. The model will be, now this model can able to understand if this kind of data comes, I need to say this label. So now coming to the prediction part, I give an input, I extract features, and I get the feature vectors. So now this feature vector will be like pushed to this classifier model. So now this model will be like, checking the features with this part with the actual features. So when these two features matches up, it will pull this label as an output. So this is how supervised learning works. You give an input data, you extract features, and give the labels and features to the machine learning algorithm. The machine learning algorithm create a classifier model. So that model can understand the data alone. So when you give a perfect data, the particular label for the data will be like given there directly. So this is how your machine learning supervised model will work. So we'll be like predominantly using this supervised learning. Yes, obviously, all the companies are started long back, 3 to 4 years back, with this supervised learning, and they have started migrating to this reinforcement learning. But in order to understand the basics, we have to go for this supervised learning and unsupervised. So as I told you, these are some of the machine learning algorithms predominantly used machine learning algorithms where you can able to, get some ideology. For example, k-nearest neighbors, logistic regression, support vector machine, decision trees, and a lot of good algorithms are there. Each and every algorithm has its own trait. Using that particular algorithm's advantage, we can able to understand which kind of algorithm have to be used. So believe me, since programming language is a very, very important part. But anyways, you can use any algorithm for an application, but you never know which algorithm will be used for which application. So that is where you have to expertise. For example, if I give you an application, you just want to understand what kind of feature you want to extract. That's first. And the second thing is what kind of algorithm you need to take care of. So you cannot like directly use a feature extractor like color feature extraction and directly go to the k-nearest neighbor. You cannot say like that. So you need to understand the application. You need to find whether what kind of data are coming. Based on that, you need to choose the algorithm. Even for deployment, some algorithms are very accurate, but it is not that fast. Some algorithm are not that accurate, but it is like very faster. So there is also we need to take care of the trade-off between speed and accuracy. So if your algorithm is very fast and it is not accurate, there will be a problem. Even though if your algorithm is very accurate and it is very slow, even that will be a problem. A classic example I can say, an autonomous car. Take the same example, autonomous car. You create a perfectly made algorithm that can able to identify human beings at any cost, but the problem is the speed of the particular algorithm is very slow. For one frame it will take 1 second. So imagine you are driving a car at 100 km/h. Obviously what will happen after 30 minutes, you will get an update like human detected. Maybe that human would have been detected 30 minutes back. It would have been detected. It would have been like telling you the data now. So we need to make sure we have the actual trade-off between speed and accuracy based on your application. It is a time. If it is a time-bound application, we need to take care of the time. If it is not the time-bound application, you can go for the accurate model. So it's up to us to do that. Because since I told about image processing, video processing will also come to that category. So we like split the videos into frames. In that frames, we can able to identify stuff. So as I told you, we are in a, I can confidently say that now you guys know about what is feature extraction and what is machine learning, somehow to some extent a mental ideology. So let me go for an example. So this is a Q&A session for you guys. Listen up. So I'm going to give you two images, and I want you to classify these two images whether the given image is a forest or an ocean. So what kind of feature extractor you will use? A shape feature extraction, or a color feature extractor, or the texture kind of a feature extractor? Which feature extractor you will go? So anyone can able to suggest me which attribute I have to take? Great, Suresh. So it's color. It's obvious. Yeah, texture can also be a part, but I can say predominantly color will be the simplest way to do it out. Texture, different scenarios, different areas, texture will be different. But ocean as a texture, yeah, trees might also have a texture. But to a simpler note, we can go for color. So if I get a green data, I can say that is forest. If I get a blue data, I can say that is an ocean. Simple, a sea. So as simple as it is. So I'm going to use a color channel statistics. I'm going to use this algorithm color channel statistics, and I'm going to extract the mean and standard deviation for that particular image. I guess we know about mean and standard deviation, right? The average of the colors, average of the data is known as mean. The deviation, the data which made to the actual mean. So that is known as standard deviation. So using these 6 numbers, you will be in a position that okay, this color, this particular image belongs to whether to a forest or a sea. So now that we have data, we need a classifier, right? So let me use a k-nearest neighbor. So it is very simple, right? So I use a k-nearest neighbor. So this blue data represent the actual, data for the sea, and this pink data will represent the actual labels for the forest. So if I get, this is my query image, and I look for just one neighbor. So this guy is very close to me. So now I can say this particular query image belongs to the category forest. Maybe let us take this image. I can say all the neighbors are belonging to the ocean. Maybe this image, it's not the perfect image. So obviously we will have some mismatch of accuracies, but we need to make sure it is very minimal. So as the first example implies, I'm using a color channel statistics to classify and two type of classes, whether it is a forest or a sea. I use a color channel statistics and I extract data and I use a machine learning model KNN to derive our application. It is very simple. So I congratulate you guys that we have officially made a mental ideology on creating an application using AI. This is great. Okay, let me go for a next example. So come on guys, what kind of feature extraction I can use now? Color, shape or texture. Which feature extraction can I use now? To determine whether the pavement is a grass or a rocky pavement. Okay, color, great. Is the color enough? Shape, okay. So that's a mixed command. So what about texture? So I'm expecting color and shape. Okay, great. So obviously color will be a crucial role. Obviously color is very different, but sometimes if I make this rocks as green color, I cannot go for color. But shape, yes, I can go for shape. Rocks have some shape, but this grass doesn't have a shape at all, right? So it is kind of a pattern, right? So I can say this grass is not having a shape at all. So I cannot say it has a shape, but this obviously has a shape. So I can say I can use a texture, right? So because this has a pattern, a pointy dot 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 kind of a pattern. This is a very big, very big circles, very big rocks as a pattern. So I'm going to use a textural feature extraction, a texture-based feature extraction for this particular example. So let me go to the algorithm right away. The algorithm which we're going to use is known as heraldic texture. It is one of the simplest algorithm where we can able to understand the patterns clearly. For example, this is my image. This 3x3 is my image, and I have these pixel numbers 3, 1, 2. Okay. Okay, sorry. Yeah. So I have input image of 3x3. I have data 3, 1, 2, 2, 1, 3, 1, 1, 2. So now what I'm going to do is I'm going to construct a matrix where I'm going to see the patterns. For example, 1, 2 appears for 2 times. So I like raise the number as 2 here. At 1, 2, I raise it as 2. Now 1, 3 appears for 1 time, and I use the number 1 at 1, 3. Likewise, I'll be going for all the pattern in the particular image. For example, imagine your image will have a very big size, 1000 x 1000. So imagine, this is just 3x3. You will get lot of similarities, lot of similar patterns, which is actually representing your texture of the particular image. So this is how the heraldic texture will work. We call this matrix known as GLCM matrix, gray level co-occurrence matrix. So where I'm going to plot the number of occurrence for all the patterns. So you can use different kind of combination. This is a linear combination. You can use top bottom approach, even this diagonal approaches as well. So as the number of angle increases, the accuracy will increase. But imagine if I increase the number of angles, your accuracy will increase, but the speed will dramatically will reduce, right? Yeah, that is obvious, because when you go for different kind of angles, each and every image, for example, let me tell you an example. I have 1000 images for rocks and 1000 images for grass. So each and every image is a dimension of 1000 x 1000. So that is a colored image. So 1000 x 1000 into 3 into 1000. So this much amount of data have to be handled to extract my features. So that will take a lot of time. When you go for number of angles, but that is also a part of the deal. But because sometimes you want a perfect algorithm, you want perfect accuracy. So on that time, maybe you can go for different angles. So now that I have got this GLCM matrix for each and every image, so this is my actual unique number where I can able to pass it down the numbers to my machine learning model. So now let me use a support vector machine, a simpler ideology like the previous. So I just plotted the data, I just drew a line. So this line can able to classify my data, whether the data belongs to a grass or a rock. So this is as simple as it seems. So I mean, believe me, I mean, this is known as machine learning, guys. So it is as simple as it is. You can say me, come on, bro. I mean, this GLC matrix. I mean, getting the I mean, the patterns. How can I do it in a code? I mean, you'll be like wondering. I mean, whether it would be a very big code to achieve it out. I mean, I will tell you the star of the show in the later slides. But anyways, believe me, this will be like very easy, very easy for you guys to. I mean. What is it? Come to this environment. So it's all about your ideology. It's all about whether it can be achieved or not. So because people, think, as I told you the previous slides, the mythical facts and the things which we have to understand, the challenges faced. If you have this mental ideology, you can able to understand what kind of feature have to be extracted and what kind of machine learning algorithm have to be used. So coming to that point, this is a basic ideology where you can able to create your own classifiers and stuff. So let me let me show you a demo. Maybe okay. Let me show you a demo where I'm going to find the emotions of the particular face. Okay. Let me show it. Yeah, fine, great. So now. I'm just running an algorithm where I'm going to find the emotion of a particular face. So I'm going to use my face. I need to comb my face. Hello guys, this is Deepan. So you can see, I'm smiling right now. So it is showing me happy. So now this is a neutral form of my face. It is showing 73 to 80% of it's neutral. So now I'm getting angry. Yeah, I'm not that good at giving expressions, but anyways, you can see, I have like categorized into 6 categories: angry, scare, happy, sad, and surprise. Maybe we'll try for surprise. Okay, it's coming as sad. Great. So this is a simple, I cannot say it is simple, but it is a neat kind of an application which we can deploy. Let me tell you what can be the steps for this particular application. So initially what I want to do, I want to create, let me go to the paint. So first I want to detect my particular face. So because in the given image, I want to look for my face. So when I detect my face, I'm going to give this face to my classifier. So machine learning classifier will be like using this cropped image, and my classifier will give me the actual label. So now to create the data set, what you want to do, you want to take images of 6 categories, right? Images of all 6 categories: sad, angry, happy, neutral. Likewise, you need to create data set for different categories. So in order to for this kind of a feature, you can use a shape based feature extractor, and also you can use facial landmarks as well, because facial landmarks is like all the face will have this unique key points, right? Your eyes, nose, and ears will be in the fixed position for all the human being. You will have the definite position for eyes, nose, and ears, and all the demographics, right? So using that key points and using some shape based feature extractor, I can able to create a classifier that can able to understand the different emotions. So here in this case, I have used a deep learning model to create this particular algorithm. So I use deep learning technique because obviously machine learning technique will have a lot of problem. You saw the video, right? The webcam which I use is not that good. It's a very low clarity webcam, but it somehow it is able to capture my my emotions perfectly because of the data, because of the challenges which I mitigated during the during the time of my training. So this is how you need to create an application. So creating application is very easy, but you need to understand which application, which kind of an algorithm you use for which kind of areas. So maybe I know we have been like, I mean, hearing this buzzword for the past maybe 2 to 3 years back, right? So AI is becoming a buzzword for past 3 years. Before that, we know only about IoT. So wherever you go, you see IoT, IoT enable, right? So now people are currently like, I mean, moving towards this AI, trend. You can also, if you buy a latest smartphone, they'll be saying AI powered selfie, AI powered, hardware. So everything is like AI powered. So now it's becoming a big trend. But you know what? I mean, lot of AI algorithm which has already been deployed, but we really don't know about it. This spam email detection, this is actually an artificially intelligent program that can able to understand the mail whether the given mail is spam or not. We just saw that, right? And also this language translation. Language translation is a very, very big breakthrough for this Google guys. They can able to translate all the languages. You have this, Google Lens, right? You have this application known as Google Translate, where you can able to, easily translate your words into a different, a different text, different language. So translation is also part of an AI. Image search. Have you tried with an image search? In Google, you have this option known as image search. You just post an image. Based on that image, it will look for a similar kind of image which is present in different websites. That is image search. And also coming to the important point, Amazon recommendations. I know, when you go to Amazon, when you go to Flipkart or some other websites, you look for products, right? But actually, you won't buy it, or you might buy it. So your history, your cache will be like stored in your browser. And now when you go to the social media, you can actually see the ads which is relevant to your search. So this is how Facebook or Amazon are like fetching your data from your cache memory, from your cache. They are like finding your interest. Based on the interest, they are giving this ads. Facebook is this is the premium selling point for Facebook. So they get the right audience perfectly. For example, if you are a student, if I'm going to like create this course curriculum, so I will say my Facebook ad like only publish this ad to students or age between 20 to 30. So that is how this recommendation works. Google News, this is also pretty being improved right now. You will get this relevant search results. For example, if I type the word anaconda, for example, let me go and type, not sure, let me see. So if I type anaconda, obviously I'll be getting the first thing which I get is the software, and after that I'll get the snakes. So obviously maybe you can try your Google. You can try to search. If you haven't searched for anaconda, if you haven't used any programming language known as Python, obviously you'll get a different search result. So Google News, Google recommendation is very different. They like read your data based on a search result. They will populate your own search results. So and some of the other usages like Facebook, photo tagging. So I guess 5 to 10 years back, they detect the face and they'll say whom you want to tag. But now, you can see, do I want to tag this guy? So they are like already made a face detection and the face recognition, and they are like suggesting, do I want to tag this guy? They directly like pull the names from the database. So likewise, there are like lot of n number of application which is being developed, and it is like being utilized all over the world right now. So current trends. So this is important because in the field of AI, I've been in this field for the past 4 to 5 years. So previously, the growth was very less. You can say, very less growth. The updation rate is very less. But now, if we like lag for 1 month, if I go for a vacation for 1 month, I'll be like very outdated. So that is how the current speed of AI is growing now. So in that point, generative adversarial network is one of the great invention in AI. Let me show you a video. You can able to understand like what this actually does. So let me tell you an ideology. This generative adversarial network, what it does is it will generate scenarios. For example, if I use a face, if I give a face image, I just tell my my network to draw an image that contains face. So it will try to draw a face that is obviously be like very, very bad. I will have another neural network that will look to this particular face. it will say this is not like a face. So go draw a different kind of an image. Likewise, your system can able to learn the particular images and you can able to use it on your application. Let me show you a video where this generative adversarial network is like used to a very great extent. So you can go to YouTube also, where you can see this everybody can dance. So this is the source subject, this is the target subject. So I'm going to take the skeletal pose of this particular source subject. I get the actual skeletal image of this particular source subject. I'm going to use the skeletal and I'm going to draw this particular girl. So this girl is not actually dancing. This is actually the video which was created by the generative adversarial network, a neural network. So from the source object, I'm detecting the pose. Based on the pose, I'm drawing the element. And based on the pose, I'm drawing this actual girl's face, because the network has learned this girl face perfectly, because I've given enough data to the neural network so that it can able to generate the data at any background or any things. So now let us see the second video, entity. This is source subject. This is the actual source to target result. But you can see there are few glitches also, because obviously, yeah, you have a very different background and you might have some problem when you generate data at the real time, because it is like very instant, right? So each and every pose, it is can able to create data easily. So this is one of the beautiful way of using this generative adversarial network, and this has become a trend right now. So you can see, you can see the background is very bad at the back, right? But they can able to extract the actual pose of the source video, which has a very bad background, very dynamic background, and they can able to actually transfer that data to this source, to the target background. So this is generative adversarial network, generating data based on given images. Till now, as I told you, supervised learning, unsupervised learning, and reinforcement and stuff, you might be like wondering, hey, what is this, man? You were saying this about, for a long time, and you are suddenly showing a very big video that doesn't comply on those four ideologies. This is actually, a part of supervised learning, because you will be given a label known as face. You will be given a label known as this girl. Only this girl will be the label. I'll be giving an image. That's it. So using that image, it will generate different kind of pose and estimation. It will learn the entire, the physical structure of the particular girl. It's like an art test right now. So you know artist, right? So if you are a good artist, you can able to draw a girl on any background, right? So that is what this generative adversarial network does. Let me show you another video. This was recently launched, because the previous videos, like from the pose, it has estimated the data, but here I'm going to use a single face. I'm going to extract the facial landmarks like this. From one sequence, I just extract the facial landmarks, and using this is my skeletal section of the face. So using this source, I have created an image for this guy. Right? So only I'm going to use this facial landmarks, and I'm going to use just one image to create lot of data. If you want to create a data set using one image, you can use this particular GAN. Let me show you a funny thing which you can see. You can see Einstein. So it is just one image, and I can able to create simulations of Einstein speaking. With just one image, I can able to generate lot of images, lot of sequences for that particular image. So you can create a living portrait with just one image. You just don't want to go to this guy. Give some. Yeah, this is funny. Mona Lisa is now speaking with us. So just one image. It is giving expression. It is talking. It is to the next extent. So this is the actual trend which is going right now, guys. GAN is the next trend right now. So maybe for few months, this will be the actual trend. But that's what I'm saying. So every 3 months, every 6 months, a new technology is being replaced, like our smartphones. You can look onto this the research paper which was developed by them, few short adversarial learning of realistic neural network head models. You can Google this, the paper in this Arxiv platform. And also this is also another paper, everybody can dance. I mean, you can also look for this research paper. So fascinating papers, fascinating stuffs are like being like created. Created day by day. I mean, everyone has started to create their own ideologies. So this can is like it's like mostly used for this. Cinema industries and kind of areas where you want to create scenarios. Maybe think for an example, you want to create an animation video, animation movie, where it will take for them more than a year to develop sequences for all the backgrounds. But what if I use a GAN and use just create one image? Using that one image, what if I can able to create all these sequences? So that is how this generative adversarial network is dominating the platform. The next thing is chatbots. I guess most of the people would have known about this chatbot after the Facebook incident. So I guess, most of the people would have known about this Facebook incident, which was happened a year ago, I believe so. What they did is Facebook guys have created a chatbot known as Alice and Bob. So because, their prime source of income is from the marketing campaign. So a lot of people will try to sell their ads. So each and every, vendor who's going to sell their ads will be, they have to they'll have some questions to ask to the Facebook, right? So Facebook representative have to talk to them, and they need to make sure, their problems have been addressed. So Facebook have thought of creating a chatbot so that it can be replace the actual representative, right? So it can be like dynamic, it can be fast. So they created a chatbot known as Alice and Bob. So it was very clear. They were going very good, but later what happens is these two chatbots have started to create their own language to speak with each other, because they made a ground rule like these two chatbots have to chat in English, but they have started to create their own language like I take you everything. So Facebook people became very scary, and they thought this is the Terminator salvation. So we need to like close this particular project, because we do it actually, right? For example, in WhatsApp, in your Facebook, when you chat to your friends, what you will do, you won't use any grammars. If you use where are you will use WRU. So we use short terms so that only you and your friends can able to understand. So you don't go for grammars. So that is the same way these chatbots have understood it, and they have started to chat to each other. So freaking chatbots are now like dominating everywhere. Any customer services, they are like integrating these chatbots. Maybe few are good chatbots and few are like very bad chatbots. But anyways, people are being chatting to chatbots oftenly in Facebook. Even your Axis Banks, banking services, they have integrated this chatbot. So chatbot is a very great feature, and GAN is a very great feature. Apart from that, you have this autonomous cars, marketing automations, AI optimized hardwares. Even hardwares, nanometer technology by Qualcomm. Their recent, Snapdragon chip. They have introduced a new nanometer technology. You know what? A lot of friends, who was working in Qualcomm, they have told me they are going to use an AI to create the actual flooring model. So a lot of, scopes are there in chip design as well. And also some other examples: sketch to image, text segmentation, sentiment analysis. These are few, topics, few areas where, there are like a lot of contribution which is happening daily. So I guess these are the some of the examples, some of the current trends which is being used right now. Till now, I believe so. I hope that you would have learned about what is AI, what is the current trend on AI, what is machine learning, and what is computer vision, and what is what, like, on a basic note. So now let us go to the code base. Let us see like how to implement it. So I'm not going to like, bore you guys with the boredom code. Okay. So we'll be introducing the actual hero of this particular session. It's nothing but Python. So Python is the code base which we are going to use. Believe me, because I'm an electronics engineer, you know the code base which I would have used. I used just C and C++. So that is not a very big, very big achievement, because everyone knows C and C++. But I migrated to Python in a week. Just a week was enough for me to migrate from different code base to Python, because Python is very simple. Very straightforward. It has lot of freewares. Since it is open source, you can contribute. For example, if you have created a function that might be like very useful for all the people, you can use that function. You can deliberately give that function to other people. So this is how Python has grown in the market, you can also, look for the actual trend in the market right now. You can see the Stack Overflow most searched question. Python has dominated Java's. So now Java, it's the second position. Python is in the first position. So people have started to use Python because it is open source, code effort is less, very easy to use, and obviously it has a lot of great libraries that assist us very easily. So skills needed for this particular course is Python, as I told you. Creativity and patience. So that is obvious. So I can say, Python is the very easiest, way of, making us to, involved in this particular AI field. So I can give you an example of Python versus C versus Java. So I really don't know about what this program does. If this is wrong, sorry for that, but it just copy paste from the Google. So not to print hello world, what you will do in C, you just want to include a header file, a main function, open and close curly braces, print of hello world, and a colon. So this is how you type for a C. When you go for Java, I really don't know what this actually public static void main does, but okay. This is how Java people will try to print hello world. But in Python, it's just print hello world. Your pseudocode, whatever pseudocode you have, will be the actual code, guys. So that is the beauty of Python. So if you want to print hello world, why you want to include a function? Why you want to include a main function? Why you want to include a colon or something like that? It's very simple. You want to print hello world, print hello world. That's it. So that is the beauty of Python, guys. You can easily migrate to Python. That is up to you to decide. You can also use Java, C++ for AI, but believe me, that will be like little difficult for us to involve in AI, because we need to know about the actual theories behind the vision image processing, the theory behind the machine learning models, and after that, using that theories, you need to create your scripts. And even if you don't have libraries, your implementation will take a lot of time. For example, as I showed the actual demonstrations of my code, right? Let me show you the actual final application of this emotion detector. You'll be surprised. The lines which I use is just 100. Believe me, emotion recognition is just 112 lines. The application, the final deployment is just 112 lines. So that is the beauty of Python. So the code, the number of lines will reduce, the actual functions and the actual libraries will help us to create very big program, very big application with a minimal number of code effort. So some of the libraries which we will be using in the course will be OpenCV, scikit-learn, Keras and TensorFlow, and NumPy. So actually in our course, we have divided into 3 modules. One is Python, another module is machine learning, another module is deep learning. It is a sandwich course. You can you can take any portions you want. For example, if you want just Python, because you can use Python for any other application. For example, you can go for artificial intelligence, you can go for network security, the Django, your web apps, DevOps, and there are a lot of areas. Python is being used. You can go for that part. Supposedly, if you want AI, you can choose this Python basics and machine learning. But if you want to explore more, you think machine learning is not enough, you can also purchase the deep learning add-on packages. So this OpenCV, scikit-learn, and NumPy will be used in the machine learning course. OpenCV is nothing but this is the library which will be used for your image processing. So all your image processing, the pre-processing, post-processing, whatever feature extraction which I told you will be done using this OpenCV library. So the actual machine learning models, the SVM, the k-nearest neighbor, decision trees, all those machine learning models will be deployed using this scikit-learn library. So this Keras TensorFlow will be used for deep learning. This NumPy is a support library for all these other libraries, because NumPy is very good at dealing with numbers and matrices. Since we are going to deal with images nothing but arrays of pixels, arrays of data. So matrices, right? So NumPy will be very useful for us to create some mathematical calculation, some creation of matrices and stuff. So these are the 4 important libraries which will be used in the course. Alongside the course, so this is how we are going to travel to the course. So we'll be using Python. We'll be using this 4 important libraries. You can Google about these libraries. These are the top-notch libraries which is being used by everyone. So using this predominant libraries and some support libraries, we'll be traveling in the course. So, and finally, I told you about machine learning. That's great, right? So I was saying about the feature extraction, the color-based feature extraction, the textural-based, the shape-based, and the machine learning models like support vector machines, k-nearest neighbor, and decision trees. Yes, that is great. But it is great to some extent. You cannot expect 100% effectiveness in machine learning. In deep learning, it is actually, it is entirely mimicking our human activity. It is actually depends on the neural network which we will create. So where there is no concept known as feature extraction and there is no concept known as machine learning models. So everything is neural network. You create a network, you give a data, the data will be like passed to the network, hidden neurons, a back propagation will occur. Based on the back propagation, the neural network will actually learn on its own. So you don't want to do a pre-processing at all, guys. I was saying you about this challenges phase, right? Challenges phase is okay, it's very important, but sometimes you have to detect things out in the blue. On that time, deep learning will be very useful because the emotion recognition which I showed you is from deep learning. Due to the various background also and very bad webcam quality, it can able to detect my emotions because of deep learning. Because deep learning uses a different ideologies than machine learning. So now you might be wondering, so then why I want to go for machine learning? You say deep learning is the best. You say deep learning is the current trend. So then, why should I go for machine learning? Believe me, there is always a thumb rule when you create an application. So it's from my Guruji. My Guruji is working in a different company right now. He said, when you want to create an application, you first want to understand the application, whether it can be applied with the basics of image processing, just the image processing alone, or you can go for machine learning, or you can go for deep learning. Because deep learning requires powerful hardware, that's one, and also it should have a lot of data sets. If we have data set of more than 1 lakh, then deep learning will be the best option. But sometimes, you might not get good data set. You might not. The objects which you have will be like very unique. You will not be like seeing anywhere. So on that time, you will have only 1,000 or 500 images. So on that time, this machine learning will be like very useful because we are handcrafting the features. You just look for this feature alone, right? So on that time, machine learning will be like helpful. When your data set is very high and it's like very normalized, not like normalized, it should be used in different scenarios and the background is very dynamic, you will go for deep learning. Sometimes you can even go for image processing also. Let me show you an example, a classic example for image processing. This is just to show you the actual ideology. Fire detection, okay. So these are the two images which I'm going to use. So this image and this image. I can create a very big data set, a very big model to detect fire, because fire detection is very difficult, I know that, but sometimes things can be made very easier. So what I'm going to do is I'm going to use just a color segmentation technique. Using that color segmentation technique, I am going to create, create a fire detector using just a color segmentation, just the image processing. Let me run the code. You can say, I just use the color segmentation. Whenever I get a yellow color, pixels, I term it as a fire. So and I just crop the areas alone, crop the area where the fire is actually present. So for the next image, I know the fire is not detected here, only in this area because this is yellowish. So I just look for yellow and I find the actual place of the fire. So this is not the perfect way of doing it out. This is just an example, but sometimes it is always better to go for image processing. For example, finding the color of the balls, maybe finding the field of the your form fields. Your form field will have lanes, right? So for that lane detection, you don't want to go to create a machine learning model or a deep learning model. Image processing is enough because the lane will be pretty different in color. Using that color scheme, you can able to create a lane detector. So using just the image processing, even for your road lane detection, your lane will be in white in color or yellow in color, right? So using that scheme, you can use a normal image processing technique to detect the lanes. So we need to understand when it should be like used in image processing and when should be at machine learning and when it should be at deep learning. So it is like, first we need to try to solve the problem with computer vision. If that doesn't work out, go for machine learning. And you should understand, while going to machine learning, if you have a good data set, if you have a very big data set, you can switch to deep learning. But when you're going to deploy the model, you need to understand the speed, right? So if you are going to deploy this deep learning model into a Raspberry Pi, a small computer that is having only just 2 GB of RAM or 1 GB of RAM, definitely it will be like very slower. Your hardware will fail. So on that kind of times, machine learning will be useful. So it's up to us, it's up to the hardware, and it's up to the application, it's up to the data set to understand which model have to be used, whether it is image processing or machine learning or deep learning. So the final, the trademark question: who is hiring for artificial intelligence? Whether I can switch to this field. I'm having a 10 years of experience in this. Software testing or SAP. Can I go to machine learning? Can I switch my career to artificial intelligence? Believe me, there is no company that purely works on AI, but there are all the companies as a particular field where they want to automate the boring stuff. So they need people who can actually understand the actual ideology of the work, and they should apply an automation technique to assist that. For example, a software tester, maybe a software tester. In that case, the testing activity is very difficult. It's a regressive activity, and that time only the tester can able to understand, okay, this part of the portions I can able to utilize and create an application using AI, and I can able to automate it out. So that is how AI is being used right now, guys. There is no particular company that actually works only in AI. So you can create opportunities in your company. Even I joined my company. There is no scope for AI in my company. So there's just automation. It's like that. So I went there. I created an opportunity where they realized, okay, AI can be used in this application as well. So this is how we need to understand, because one of my students has been asking me, I got placed in TCS. So is this the right place for me to go? I just want to use AI. Wherever I want to go. I just told him, TCS is a great company unless and until you try to do some AI application, because everywhere and whatever company you're going to join will require AI. So that is the beauty of it, guys. So it's not like a particular company. I'm going to talk for only Intel, or I'm going to talk for only Google. It's not like that. You can create opportunities for AI. So coming to that fag end, I just want to show you a small application where I'm going to detect my actual hand. This is, tell me, after I run the code, just tell me whether I used image processing or machine learning or deep learning. Let's see, who gives the right answer. So, hi again. So, okay. So, yeah. So, do you think I have used machine learning or deep learning or just image processing? So, what do you think? So, what kind of algorithm I would have been using here? Any ideas? Anyone? ML, great. Okay, we can use an ML. That's great. Great, Suresh. Yeah, image processing is a pretty okay. Deep learning is also can be utilized, but I can say image processing will be the easiest way, because we should go for the easiest way to create an application. Always we should not think deep learning will work. Always we should not think machine learning will work. Image processing is enough for me to detect the ant, right? Because my ant as a particular color, a skin color can be have some different format. Threshold of the skin color will be in the range, right? I can use that skin color threshold, and I can able to see the motion detection. For example, change in the background with the foreground. As I run the code, you can see number we're counting, and given like calibration completed. So it is like calibration completed in the sense. Can have many movements and views as well. Yeah, exactly. Yeah, that's what I'm saying. So, but on a simpler note, because when you deploy this hand detection in a very different background, obviously image processing will fail. That is obvious. So I just want to make sure, okay, if I has a very plain background, obviously image processing will work. But if I go for a outside environment where my background is very dynamic, on that time, obviously your image processing will fail. We'll try to switch to machine learning. Even machine learning will not be that helpful. On that time, we'll be go for deep learning. So actual ideology is like you have to understand for which application we need to use which kind of techniques. Because we have formulated the course in a way where we don't teach you just the codes and teach you like what is what. We teach you like where to utilize this code and where not to utilize the code, where to use the perfect feature extractor and where to use the perfect machine learning classifier or a deep learning classifier or image processing. So we'll be giving you some perfect case studies and some assignments as well. On that time you will be in a position to make your own decisions, because people tend to fail because back in the days I was failing a lot because I don't know like which algorithm to use. I don't know whether to go for on a particular time I learned deep learning. You know what? For every application, I use deep learning. For every application, even for a small coin detection, even for a small pencil detection, something like that, I use deep learning. So because I was fascinated with the word deep learning, and it created a lot of attention. Even I created a lot of papers with deep learning, 4 to 5 papers. You know what? It just that doesn't need deep learning at all, but it's a fancy keyword which people are using. So I just want to make sure the mistake which I have done should not be done by you, because I have wasted a lot of time in like identifying in knowing what kind of algorithm have to be used and whether can I use a deep learning model there or a machine learning model. So I don't know much about it. So when I gain experience, I can't know this is the right way. Maybe this might be the right way to create an application. So we have sprinkled our experience in the actual syllabus. So when you go to this course, you can say I can say you just not learn only the AI. You learn how to develop and how to deploy it as well. So we'll try to teach you like how to deploy it in real time. How cannot be deployed in real time, some worst case scenarios, some best case scenarios, some thumb rules and stuff. So that is how we'll be like working things out. So because I've showed you pretty great things, but I also, you know what, there is another community which is trying to hack this, hack the neural network also. The cyber security, the networks, the security system is also little bad in deep learning and the artificial intelligence. Let me show you a video where they have easily cracked it. For example, you can see this is a very perfect architecture. Google's Inception v3, that was the architecture which was created by Google. It is a very good architecture that can able to detect multiple objects at the given time. You can see this person is being detected. Even when he moves back, the chair is being detected here and there. But this person is not being detected at all, right? It's like very clean. You cannot able to see. The model is failing to identify, failing to find whether he's actually a person or not. So now see, he's just moving the he's moving the image to the reverse position. Now it is showing person. So that's the thing which I'm trying to say. So the person is not being detected. Imagine an autonomous car. That's the prime application should be like human detection. On that time, if I have a perturbation activity like this, obviously you will be in a very big position, very big dilemma. Very big problem. So now see, now you have changed the that object to another person. Now he is being detected, he is not being detected. So this is known as perturbation effects of deep learning, spoofing the deep learning models, spoofing the AI models. So this is also a current trend, guys. A lot of active research is actually happening there. So it's like what they actually do is they just create some noise. This image is there, right? So they have some noises here inside it, which we don't see actually. It's in the form of data. So that data will confuse the model. And say, that is a null data, that is a background data. So because of that, your model fails miserably. So that's what I'm saying. So it's not like AI is always great. AI can do everything. So there are like, objectives where AI can fail, objectives where people can able to, attack AI models also. So imagine when you create an application that has a functional safety and you attack the model. So what will happen? So it will be a very big dramatic situation. So this is also a current trend which is being like circulated in online. So you can also get some insight. So it's all about keeping you posted. You want to be like very up to date, so that you can able to catch up with the actual pace of the AI world. So I can say AI is not it is not went to that extent. You can catch that very train which we are traveling right now, because AI is young. It is just 5 to 6 years old. Based on the current demands, it is just 5 to 6 years of hands-on experience. You can go for job notification. You cannot see 15 years experience AI professional is needed. If they like put a job notification like that, then they don't know about AI. You can see managerial position will come for 5 years experience. Technical delivery manager will be like 5 years of experience. So that is the current trend, because only 5 years, for the past 5 years, this has shooted up, and a lot of people have actually practically been working in this area. So just 5 years. But think about the works which we are doing will be like actually 20 to 30 years old. Maybe for few engineers, for few people, not for everyone. But this AI is very young, so you can catch up easily, and we make sure you catch up to that very particular point. And you know what in this course we are not going to we obviously will give you the materials. The classroom training will be happening, everything will be happening, but we'll be giving you a lot of assessments, lot of application which you will be publishing in your LinkedIn profile, because you need to make sure you are going the right direction. So we'll be creating some challenges, some on the spot events where you can able to do it out. So we categorize this course into two things. One is like fast track course, another one is the total content. Let me show you the total content. So this is the actual total content which we plan. So Python will be giving you for 10 hours, and ML will be 40 hours, and deep learning will be for 20 hours. So Python is up to you guys to decide, because I'll be giving you a basic insight of Python, and we do have an isolated course for just for Python. So we have another course structure where we'll be dealing only making you to master in Python, because obviously programming language is little bit needed. For people's working in the managerial point of view, we have a unique teaching methodology where we won't teach you the codes. We teach you as a recipe. For example, I can show you this hand detection. Maybe take this one. So I can say this particular piece of code will define my ROI. This particular line will help me to resize the image. Likewise, we'll be not teaching you the syntax. We'll be teaching the syntax, and also we'll be teaching you the recipe of the code. So using the right recipes, you don't want to actually mug up the syntaxes. That is old school way. So we just use already made code. We edit our way, making sure we can able to understand the code. That is enough. So on that point, if you are already well versed in Python, and somehow you have some knowledge in Python, this 10 hours is more than enough. For the people who already been working in programming languages, any programming languages, C, C++, Java, PHP, any programming languages, 10 hours is enough for us to migrate from one language to Python. But for the people who doesn't know Python, doesn't know programming language at all, we have to take some extra effort to learn this programming language. For that, we have a separate course for Python, which Mubarak will be telling you later. And also coming to deep learning, machine learning will be like 40 hours. We'll be having 40 hours content where we'll be covering, setting up the environment, because setting up environment is a very big, problem. Because back in the days when I started to create, started to learn this AI, I find it very difficult to, install the libraries of Python. So it's very difficult. I use a Visual Studio and do lot of things, lot of steps will be there. And I find it very difficult to install. But now it is somehow easier. But anyways, we'll teach you how to install, how to set up your environment in your system. And then we'll go for some basics of image processing. This will cover the actual important basics of image processing. And then we'll go for feature extraction. So this is not limited to this, feature extraction alone. I'll be giving you insights about other feature extraction which can be used also. So a basic ideology on how to use a feature extractor. So the next thing is I'll be going for some image classification technique, machine learning algorithms. So how to use this algorithm. And finally, with some case studies. So object tracking, human detection, face detection and recognition, drowsiness, and much more current, demanded application, which will be useful for you guys as well. So till the 7th topic, will be, yes. Hello.
Yeah. Hello.
Yeah, you want to say anything?
No.
Okay, yeah, great. So till the seventh portion, I mean, you will be going for machine learning, and from eighth, we'll be like dealing with deep learning. We'll be learning about the convolutional neural network, the multi-layer perceptron, I mean, the back propagation, all the stuffs, and we'll be going for some object detection and some state-of-the-art networks, which was created by very big companies like Google, Intel, and stuff. And also, we'll go for some other, I mean, neural networks like creating neural network for sound, text, and data. Then finally, we'll go for emotion recognition, I mean, age and gender detection, object detection, and much more. So this is the actual course structure. So if you decide to go for machine learning, you can take machine learning. That is enough for us. But for some people, if you're like very interested to even take the add-on material, you can also go for this extra 20 hours. So coming to the fast track course, I mean, this is the entire course structure. When you come for the fast track course, this is just 18 hours and 7 hours of DL. This is optional. And this 10 hours of Python will be given you as an offline handout. We'll be giving you some, I mean, handout materials where you can learn on your self-paced environment. So here I'll be like, I'll be like giving you a crispy way to, I mean, design stuff. For example, because you don't want to learn all the things to create an application. You just want to know the right things to create the right application. So in that point, I'll make sure, I mean, given any application, you will be in a position to create an application. So each and every in image processing, I'll be like showing you like a crispy way to do an image processing, and also a skeletal structure to create a machine learning model. So we have made an architecture where you don't want to change the code at all. You just change the data set, and you can easily create a classifier on your own. So that is how we have made it. Computer vision basics, and also deep learning will be like giving you, I mean, one examples on how to create your baseline architecture and your case studies. So it will be like more of a self-paced learning. We'll be giving you all the materials which will be used for the 60 hours course, but the detailedness will be like very less, but we'll be giving you a crispy way of, I mean, handling your AI application, because some people won't get time for 60 hours. That will span for at least a month or so. So we'll be going for a fast track course, but the support will be the end. I mean, we'll be giving you a lot of support. Any time you can contact us and you can do it out. So this is the actual ideology. This is the actual structure which we are planning right now. And believe me, I'm going to create a Guinness Book of Records at the end of this year. So I'm going to plan for more than 2,000 audience and a single arena where I'm going to and teach them some basics of AI. So that will be one of the record which we are going to make. So if you want to be a part of that, even you can contribute. You can come to this course. You can be a part of this Guinness Book of Record as well. So it's like a mutual understanding between us. So whatever journey which we go and whatever things which we do, we make sure we keep you there. I mean, it's just things which you want to know. So the basic ideology is like you can compare to any online courses. There are a lot of good courses. I believe. I mean, there are like a lot of good courses. But the thing is, I have tailor-made in a way where you can actually learn the essential part, because in internet everything is there. Even the data which you're going to take some code will be all obviously will be in the internet, but how we are going to use that code, how we are going to learn it. So that's the area we'll be like teaching you, because back in the days, because I didn't learn any courses, I just learned on my own. But it took me 5 years, maybe 4 years for me to master this stuff. But since I know the right way to address these stuff, you are in a better position where you can able to easily master this technology. Obviously, it will take some time. After the fast track, you can breathe. You can breathe in. You can take a week or so to create your own application. So we make sure we do that. So do we have any questions? So do we have any question in any clarification on the slides or something like that? So any interesting topics which you want to know? Any other current trends which I missed, which people have, which you would have been thinking that we covered as well. So please let me know so that we can do other topics.
If you have any questions, you can unmute yourself and you can discuss with Deepan. This is a good platform to answer your queries. If you have any questions, you can unmute and you can ask Deepan.
Any question?
Here, how much statistics
we are going to use? Like for data science, how much statistics we need? Do you have any idea about that? Like, because
Yeah.
that's a question for me, because I sometimes think I can go and do some statistic course, but someone says you're not required to read entire statistics. So how to know how much I need to read about the statistics?
When it comes to data science, when it comes to statistical point of view, I mean, you just want to know the theoretical part. I mean, even in this machine learning algorithms in the computer vision parts, image processing, right? I mean, there are like a lot of, what is expressions and stuffs which have to be mastered, but we don't want that actually. We just want to know the theoretical part. That's it. Not just going very deep into that. So in the statistical point of view, you just want to know the actual working of the statistics. For example, there'll be a lot of techniques, right? So you just want to know, I mean, on a third man point of view, how you use this algorithm. So when I give an input, I get an output like this. So how it is happening? It is happening. It is using some logic like this. So if this higher level of understanding is enough for us to, to get us involved in this area. So, but anyways, if you are going in a research point of view, this is, whatever things which I'm saying is like applied machine learning. There's a difference between these things. Applied machine learning is like, I mean, since we are already into the market, we are like already working, we cannot go for mathematics, we cannot go for statistics and learn that to the core and after come to the, machine learning. So it will take us a lot of time. So we are going to learn like what can be used, how can you embed this, technology to an application. So we are going to apply the machine learning models, not just invent a new architecture. We are going to use the already used architecture, but we are going to create different application which has not been addressed at all. So that is how we are going to traverse.
Okay, fine. Thank you.
Yeah, great. That was a nice question.
Yeah. So it will be not tough, correct? Like someone suppose don't like math. It says if you don't like math, it may not be the field for you. So we can go still if we can try with what we need in the statistics. Okay.
Yeah. Just a higher level understanding is enough, guys.
Okay.
Just an high level understanding. So because we are going to apply the models, not. If you're going for an R&D, if you're going to create a new neural network like generative adversarial network or something like that, then you need max. But most of the people will try to automate stuffs. Even I do that. Even I'm taking algorithm which was used in a different scenario, using that algorithm, merging one or two algorithms, and creating my application as per the need. So that is enough, I believe so.
Okay, fine.
Yeah, great.
So what are the prerequisites which you have to learn before learning here?
Sorry, can you come again?
Kushal, your voice is not clear. Can you speak louder and clearly?
Okay. Is this correct? Hello?
Yeah.
What are the prerequisites which I have to learn here?
Yeah, prerequisites is only Python. That also just the basic syntax, like how to develop some code in Python. That's enough. Even though we will be giving you the handout materials, basic handout materials where you can glimpse your Python skills. If not, if you are not confident that this skill is not enough for me to go into AI, you can also take a course in our company, or you can also learn it on your own. That's up to you to decide. But a minimal coding knowledge is required for this AI.
Okay. Thank you, sir.
Yeah, great. Do log into a site. Do see the syllabus and do chat with our administrators. Check for the contents and stuff. Check for the clarity. If you have any doubts, any concerns, you can mail us anytime. We will make sure we deliver you the right answers to it. And also now you have the right time. You can ask me any questions. Only in AI, not the other fields. Okay. So, any other questions? Any other doubts which I want to clarify?
So it's not regarding the subject. It's like how this course is gonna be like executed. It's online definitely, but when it's going to start and what are the process that be known later or now?
Yeah, actually, I'm working in real time. So obviously we'll be, I mean, most of the people who attend here might be like working in real time. So we'll be having the classes on Saturday and Sundays, only on the weekends. But we will make sure you will be like pretty occupied on the weekdays as well, because we'll give you some small assignments at the end of the course, so that you'll be like, I mean, somehow like working in that course as well. So that is how we have planned. And Mubarak will be giving you a good insight on that. Mubarak, I mean, can you like, I mean, tell them like, how it will be?
Yeah, it depends. Once you are registered to the course, it depends. We'll conduct 2 hours per day in a weekend. Still, we have not planned. We will sure you. We will come back to you once it is scheduled.
Okay, fine. So it's like going to be the plan not yet decided. It will be still in the process.
We have planned in the process. We have already planned, but dates are not confirmed.
Okay, fine.
Okay, we will keep you informed. You can visit to our website. You will come to know when it is planned.
So it's a institutes or like a company. Just to want to know.
This is the IT industry, IT consulting.
Okay, it's IT consulting.
Yeah.
Any other doubts?
Not from my side.
Great. Yeah. Even if you get doubts after the session, you can mail us.
Yeah, sure.
Yeah.
But thanks for explaining in such a way, and you are pretty much confident. So that like your presentation.
Great. Thank you. Thanks for the compliment.
Yeah. Any other questions, guys? This is a good platform. If you have any doubts on artificial intelligence, you can clear it now.
Before I just got a question again. Sorry. So I was looking into various websites like MIT and ISB, their courses. So
Okay.
I got confused myself. There is a course called data science, which I have now idea after attending a lot of sessions in different platforms. I know what is ML, I know what is AI, but a
Okay.
separate course they are providing that is called big data analytics. So I thought data science itself is a big data, but someone explained when you are applying data science on big things is called big data. So for that, they are giving a separate course for a 5 months or 6 months.
Yeah. Actually, like data science is the, I mean, very big wrap where AI will be a part actually. So
Yes.
only we make some decisions, and that decision will be go as a statistics, and from there we do an analysis. So big data, I haven't been involved in big data. So I've used small, data analytics, not in big data. So I cannot, I'm not at liberty to, answer that question.
Okay, fine.
Anyways, that involves some big data. Maybe the platform, maybe the architectures might be different, because as you see in machine learning and deep learning, you have a difference, right? So maybe like that. I'm not sure about it. I cannot comment on it.
Okay, fine.
Others, do you have any questions? Bharat?
Yeah.
Do you have something?
No, actually, I am a part of EH Technologies. I've been a mute spectator for today's session. So hello to everyone. I'll be just wrapping up this session. It was very nice to have you guys over here taking up this course. And I sure hope that this has added some amount of value to what you had come here as and take as a takeaway. So the main agenda for you actually after this course, for anyone who is trying to find the next course in order to plan the learning path and make a career in AI and ML would be to actually take up the fast track course which Deepan announced during the program. So this course will be up and running in a couple of weeks. We are going to be going in a batch filling manner. I think one of the participants were asking. So as all our courses are not pre-recorded, which means we don't dole out videos which you people are going to be viewing. These courses will be in batches in real time, the way in which you attended today's session. So we are planning to have it on weekends. So we need to schedule it along with our other courses which are already running. So if you guys are interested, you can always drop us a mail, or anyways, we'll be sharing a mail with you guys after this session for you to actually respond to and let us know if you're interested in proceeding with the fast track course. So once you guys have registered, or once you guys have enrolled, we'll be sharing the commercial details and other things so that you can finally take a decision and move on. So we'll also be providing a certain amount of career-oriented training as well as screening, because we have been taking IT training for the last decade or so. So this has been a forte for us in terms of grooming people to get into their dream jobs in IT. So in terms of resume screening and mock interviews will also be a part of this package. So more on this will be told over a mailer, and we'll be informing you as the day goes by. So I think this is all I have for this session, and I must thank Deepan, who spared his time to be a part of this free bootcamp session which we provided, and Mubarak for moderating it. So I think Mubarak, you can close this.
Thank you, Bharat. Thank you, Deepan. Thank you, guys. It's a weekend, we understand, but you took your time and interest to attend this session. We will be sending you the feedback link by email. You can provide your feedback. Please provide your valuable feedback. If you have any inputs, you can just add on there. We will take it further. If any improvement is required from our end, we'll take it further. Thank you everyone. Thanks, Deepan.
Thank you, Mubarak. Thank you, Bharat. Thank you, everyone. Thanks for your patience. Thanks for listening to this course and session.
Yeah.
Thank you.